Fundamental technology. 1. Bolt. Bolt selection procedure and design considerations in engine design. In engine design, bolted joints are critical structural elements that determine overall rigidity, sealing performance, and durability reliability. Bolt size, quantity, undé-riad length, and tightening conditions must be selected based on a comprehensive evaluation of joint functionality, load conditions, and assembly workability. The following outlines the fundamental procedure for bolt selection and key design considerations. Examination of fixing method. First, clarify the required functions of the joint, positioning, load transmission, sealing, stiffness retention, and determine the appropriate fixing method. In principle, frictional joints which support loads via friction generated by clamping force are primarily used. For components requiring high positioning accuracy, such as auxiliary attachments, a hybrid type combining frictional fixation and dowel pins is adopted. Selection of bolt type. Depending on the application and installation conditions, select from hex bolts, flange bolts, or stud bolt plus nut configurations. In high temperature areas, stud bolt plus nut combinations are often used to localize thermal effects. The standard bolt material is carbon steel, strength grade equivalent to 7T. When necessary, use high-strength steel, 9T, or heat-resistant steel, for example, SUS, SUH. Determination of bolt size. Based on design loads and sealing requirements, determine the nominal diameter from the required clamping force. Use torque tension characteristics and allowable bolt stress to provisionally determine the M size. For structural components, combine analytical stress calculations with proven design precedents. Determination of bolt quantity. Bolt quantity shall be determined according to the following criteria. Calculate the required total clamping force, and determine the necessary number of bolts based on the allowable axial force per bolt, detailed load calculation required. For covers and intake manifolds, refer to established design data for maximum bolt spacing that ensures sealing performance. For structural and moving components, determine quantity based on both detailed analysis and past design experience with similar structures. Determination of tightening torque. Tightening torque is specified according to the bolt strength grade, 7T, 9T. Normally, 7T bolts are used. 9T bolts are adopted only when the required clamping force cannot be achieved. However, mixing 7T and 9T bolts of the same size within a single component is prohibited, as it may cause assembly errors and confusion in torque management. Determination of undé-riad length. Undé-riad length is selected based on surrounding bolt specifications and the conditions of the clamped parts. Since a 5 mm difference in undé-riad length is visually indistinguishable, it is recommended either to standardize lengths or to ensure a difference of 10 mm or more to prevent mesassembly. Recommended thread engagement lengths are as follows. Nut fastened joints, bolts should protrude 0.3 threads beyond the nut. Cast iron or steel components, engagement length greater than or equal to nominal diameter, e.g., M8 greater than or equal to 8 mm. Aluminum components, engagement length greater than or equal to 1.5 times nominal diameter, e.g., M8 greater than or equal to 12 mm. Insufficient engagement length may cause plastic deformation and thread stripping during tightening, design accordingly. Tightening method to avoid, 1-step bolts. Step bolts have short elastic extension and poor capability to maintain axial preload. They are unsuitable for high reliability joints in engines because they are prone to loosening and cannot ensure sufficient durability. Use should be avoided. Tightening method to avoid, 2 floating, non-seated, tightening. Tightening in the air, where the joint seat is not fully established, concentrates external load entirely on the bolt, potentially leading to bolt fracture or buckling. Always ensure full seating of the mating surfaces before tightening. Tightening method to avoid, 3 prevention of thread runout due to incomplete threads. When using fully threaded bolts and thin plates, pay attention to the position of the incomplete thread portion. For high-temperature components such as exhaust systems, heat-resistant steels such as SUS or SUH should be used to prevent loss of clamping force due to thermal effects. From a workability perspective, bolt specifications should be standardized as much as possible within the same component, assuming the use of impact or torque wrenches. Anti-loosening measures are generally achieved through adequate preload safety margins. Double nuts are rarely used due to poor repeatability in assembly. For critical components such as propeller shafts, lock nuts may be employed for fail-safe purposes. By systematically evaluating fastening methods, bolt specifications, quantity, grip length, tightening conditions, and workability, high reliability, operability, and repeatability can be achieved in engine fastening design.